In this video, we're going to be talking about parallel and perpendicular lines, but well, I shouldn't say exclusively, but primarily focused on the relationship between the slopes of parallel lines and the relationship between the slopes of perpendicular lines. So we're going to start off with parallel lines. Parallel lines are kind of the easy one. Here you can see that we have line A in the red and line B in the blue. And so we're going to look at the slopes of these two lines. So if I want to find the slope of line A, I need to pick 2 points on this line, and I'm going to count the rise and the run between those 2 points. So this is going up 1 and over 2. So when I write the slope, I have the rise divided by the run, and that's a fraction that can't be simplified. I'm going to do the same thing for the slope of line B. I'm going to use this point and this point. Find the rise and the run, which again is 1 and 2. So the slope of this line is also 1/2. And this is going to be true for every set of parallel lines you ever see. Parallel lines are two lines that never get any closer together, never get any further apart. They always remain the exact same distance apart, which means that they have to have the same rate of increase or the same steepness to them. So parallel lines will always have the same slope, and it has to be exactly the same. It can't just be close. If it's not exactly the same, then they are not parallel lines. So now let's look at perpendicular lines. So for perpendicular lines, we have this red line A that's going up with a positive slope. And then we have this blue line B that's going down with a negative slope, and it looks a lot steeper than A. So let's investigate the relationship between their slopes. So for line A, I need 2 points. I'm going to pick these same 2 points that I picked before, and I see that this is going up 1 and over 2. So line A has a slope of 1/2 also. Line B, I'm going to use this y-intercept and this next line, this next point down here. And again, it doesn't matter which 2 points you use. Slope is consistent. So whether you use these 2 points, I think on the paper copy of the notes, if you look at the key, I used these 2 points up here. You could use 2 points that are farther apart. You just have to do more simplifying. But anyways, back to the slope of line B. The rise is actually down 2, so the rise is a -2, and the run is 1, so -2 over 1. This is going to simplify. We never want to leave 1 as the denominator, but seeing it like this might help us see the connection there. But I am going to go ahead and simplify it. Anything divided by 1 is just itself. So looking at these, they have the same numbers, but they're in different places. So we have 1/2 here, and then for line B, we have 2 over 1. So they are reciprocals of each other. Remember the reciprocals when you flip the fraction. And we also see that this was positive and this was negative. And that is going to hold true for any set of parallel lines that you ever see. Perpendicular lines are always going to have opposite signs and reciprocal fractions. So they are opposite reciprocals. So there are really 3 categories. 2 lines can either be parallel, they can be perpendicular, or they can be neither. So if they don't meet the exact requirements of being exactly the same or exact opposite reciprocals, then they're just neither. So I have a couple examples for you where you're going to have the equations of 2 lines. You're going to have to compare their slopes and decide if they're parallel, perpendicular, or neither. Some of these are going to be really easy to just get the slope from like that because of the form that they're in. So for example, in this first one, our first equation isn't really in any particular form, but our second one is in slope-intercept form. So I don't need to do any work with the equation to see that this line right here has a slope of 4/5. The slope is always the number multiplied by the x variable. This one is not that way because there is still a 4 in front of the y. So I'm going to finish solving this equation for y so that I know exactly what the slope is. So I'm going to rewrite it down here. And in order to get rid of this 4, I'm going to be dividing both sides by 4. A lot of times it's going to be much easier to understand what's going on if instead of just dividing this whole side by 4, you divide each term by 4. Those are equivalent thanks to all of the rules around fraction, addition, and subtraction. So whenever we have the same denominator, we can add and subtract what's on the top, so it's sometimes easier when we're trying to simplify if we leave it as 2 separate parts. So this cancels. We have y all by itself. This, I'm just going to pull the numbers out in front of the x. So I'm going to write this as negative 5/4 x. And then 12 divided by 4 is 3. So the slope of this line is negative 5/4. And when I look at these two, they are reciprocals, the fraction got flipped, and they do have opposite signs. So these are opposite reciprocals. And I'm writing this in your notes. You would not have to write that on a worksheet. What you really need to do on the worksheet is make sure you tell me which of these 3 categories they fall into, which in this case is perpendicular. So make sure you're writing the relationship between the 2 lines, because that's what the question is asking. Determine if the 2 lines are parallel, perpendicular, or neither. So this part right here is the answer. In our next example, I'm doing the same thing. I'm going to decide if these 2 lines are parallel, perpendicular, or neither. So this first one is in standard order because I have the x and the y on the same side. And it's not real easy to know slope from that. So we're going to have to solve this equation for y. So we'll go ahead and do that right here. So 2x minus y equals negative 3. I'm going to move the x term to the other side so that I have negative y. Now, I'm going to rewrite this so that the x term comes first. And as long as I keep this sign with the x term, that's fine. So this is negative 2x minus 3. So I'm just switching the order, which the commutative property allows me to do. Now I need to get rid of the negative that's in front of the y. So that negative is the same thing as a negative 1. So I'm dividing everything by negative 1. Dividing by negative 1 has no effect other than flipping the sign. So this is going to simplify to y equals positive 2x plus 3. So the slope of this top line is positive 2. When I look at this equation, this is in point slope form. It's y minus the y value of a point is equal to the slope times x minus the x value of a point. So I don't have to rewrite this equation in slope-intercept form to know the slope. The slope is this number right here in front of the parentheses. So the slope of this line is negative 2. So these 2 numbers do have opposite signs, but they are not reciprocals of one another. So in this case, they're not parallel because they're not exactly the same. They're not perpendicular because they're not reciprocals. So these would fall under the category of neither. They're just 2 lines that are going to intersect, but they're not intersecting at 90-degree angles to be perpendicular, and they will intersect, so they're not parallel. So at this point, there are a few options of assignments for you to practice. Oh no, wait, that's not true. I think there is one assignment where you're specifically practicing, the other mild assignment where you're specifically practicing, are these lines parallel, perpendicular, or neither? Or you're going to be given the equation of a line, and you're going to have to give the slope of a line that's parallel or perpendicular to it. This lesson, though, is a huge building block for lesson E. So it's very important that you understand how we can find information about parallel or perpendicular lines when we know something about that relationship. So while there's only one mild assignment, if you don't feel real confident in your ability to be able to give the slope of 2 lines that are parallel or perpendicular, please make sure you practice that second mild assignment, the one from the bottom row that is also on Delta Math.